Hello everyone, ready to talk about service boundaries. So this is my first ever time in Latvia, first ever time in Riga, so I'm very happy to be here. Very happy for you to be joining me for the next 50 minutes. My name is Adam, and I originally come from the UK. These days I live in Switzerland, and I work for a company called Particular Software. We're the makers of a product called N-Service Bus. Has anyone here heard of N-Service Bus? Oh, great, that's quite a few of you. Okay, so I'm not going to talk about that today, but I will mention that Particular Software, our mission as a company is to make organizations better at delivering and maintaining complex software systems. Now, in doing that, we talk to a lot of people. So we come to a lot of conferences, we go to meetups, user groups, we have customers raising support cases, and we have a lot of very interesting conversations around problems that they're having. They tend to kind of be around things like problems shuffling data around, versioning components, deploying things together because they're coupled together. And it's very often when we have these conversations, we realize, you know what? If the service boundaries were slightly different, if you'd split this thing up in a different way, we may not be having this conversation because the problem you've come to us with may not exist. And we realize that so often in these conversations that I think it's really important to talk about service boundaries. I think it's one of those things where if you think about one problem can lead to other problems, can lead to other problems, or avoiding a problem can lead to avoiding a lot of other problems. It's one of those things that's at the root of the problem tree. If you get your service boundaries right, it avoids so many problems further down the line. So that's why I think it's really important to talk about them. Now, in doing this, I am going to quite deliberately take a lot of things you may be familiar with and a lot of things we've used in the industry and kind of rip them apart and turn them upside down, right? And I do expect that to raise questions. Now, I've got a lot of stuff to cover. I don't know if I'll have time for a Q&A during the session, but I'll be around for the rest of the afternoon. So, do tap me on the shoulder and challenge me on this stuff. I really like to have conversations about this stuff. Okay, so let's dive in and look at a system. Now, this is a system. It doesn't really matter what it is right now, what it does, but we do tend to organize our code a little bit like this. We don't just write program main and write everything in there. I hope you don't do that. I used to do that in the 80s when I taught myself BASIC, but things have moved on a bit since then, and we use, I don't know, they could be classes, they could be functions, they could be methods, doesn't matter what they are right now. That looks quite nice, actually, that diagram right now. You can kind of see that there's an area of responsibility up here, there's another area of responsibility down here. You kind of see what talks to what, and you might print this out and put it on your wall and kind of admire it. But what tends to happen is, we work with business people, we work with users, and sooner or later, a business person will kind of burst into your workspace and say, I was out playing golf last weekend, I've got this fantastic new idea, I think we're going to make a ton of money with this, and you kind of scratch your head and think, okay, it's not really, this is a bit of a surprise, but I think we can do it. What we're going to need to do is we need some data in a class up here for some class down here. And you think, well, how are we going to do that? How are we going to get that data across? It doesn't really fit with the diagram so well. We could kind of try and move things around, or we could just make the call, right? Classes are designed for this, right? Object-oriented programming languages are designed for a class to call a class, and they might have nice interfaces, nice public interface. If you don't violate that and do something horrible with reflection, why not make the call? So you kind of say, well, let's just dive in and see what happens and make the call, and you release it into production and it works and everyone's happy, right? And you're making more money. Sooner or later, the business come along again and said, I was out, jet skiing with my buddies last weekend. We got this fantastic new idea. And you kind of think, well, I need some data up here from a class down here. And you think, well, the last time we did that last week, it kind of worked out quite well, right? It didn't cause any bugs, Again, it doesn't really fit the diagram so well. Let's just try and do that again. And you make the call, and it's fine, it's working, and everything's in production. Sooner or later, you end up doing the same thing again. Now, you know where I'm going with this now, right? Given enough time, right? And it can be, time is the factor here. 3 months, 6 months, a year, 18 months. You may slowly start to find yourself in this kind of situation where you've got kind of red lines going in all directions. This diagram starts to lose its value. You say to your colleague, yeah, that thing we did last week, did you use a system diagram for that? And they said, what, that thing? I haven't used that for months. It's useless. It's like a plate of spaghetti. I don't know what's going on the thing anymore. So what that means is we may as well take the lines away and have a bunch of boxes. Now, these are still classes. Each one of these classes might look quite nice in isolation. It might have a nice intention-revealing name, nicely formulated methods and properties. Problem is, though, it's difficult to know what to change to introduce a new feature. You kind of have to make a change in one class, see what you've broken, make a change somewhere else, and you end up on this kind of code safari, right? Navigating your way around this thing. And it's a tough situation because you can't look at an individual class and say, yeah, to introduce that new feature, we need to change that class. You've got to go on this exploration phase. So the boxes don't tell you that much either. You may as well just have one big box. And at this point, this is what some people refer to as big ball of mud. Right? And when you're working with this, it does feel a bit like that guy looks. You know, it's not a very pleasant experience. Has anyone seen this architectural style during their careers? That's most of you. It's a sad thing to say, but in my career, most of the systems I've worked on have followed this architectural style. Now, it is a sad thing to say because we know we can do better. Right? We read about service-oriented architecture, we read about microservices. I'll come to microservices a bit more specifically later. And we know that if we split these things up into some kind of services, we can think about one part of this at a time, and hopefully this will help us. We don't have one single big ball of mud anymore. And we want them to be loosely coupled. Right? I've drawn very small lines between these deliberately. Don't want to be super coupled together, we want loose coupling. Now, again, that looks quite nice right now. But sooner or later, that business person is going to burst into your workspace and say, I've got a great new idea. You know, I was out, what was I doing this time? Playing football at the weekend. Great new idea. What do you think? And you think, well, yeah, we can do it. But what we need is a piece of data in one service from another service. And this might be something really innocuous, like the price of a product, right? 100 euros, right? It's just a number, okay? How much harm can that do? It's still loosely coupled. It just means we just need to alter that interface a bit, right? Now, that's what these services are designed for. So we change the interface, we make the call, we roll out into production, and everyone's happy, right? It's making money. Sooner or later, they come along again and say, you know, I was out, what was I doing this time? I know, I was meditating last weekend, I had a great new idea. What do you think? And you realize that you need to do the same kind of thing again. And it might be, again, something really innocuous, like the number of products in stock, right? 50 widgets. It's an integer. How much harm can that do? So again, you change the interface. And you know where I'm going with this, right? No one sets out to make a mess. No one deliberately wants to create a mess, but given enough time, given sufficient time, 6 months, a year, 18 months, 2 years, you may end up with something which looks a bit like this. Now, we've already seen that we can take the lines away. We've already seen that we can take the boxes away for all the same reasons again, and we're back to the big ball of mud. Only this time it's a big ball of mud with a difference, because you've rolled it out into 4 machines. They're all talking to each other over the network, right? It's a lot more expensive than class-to-class in-memory calls, you know, even if it's local host. You probably have to roll out 2, 3, or all 4 of them at the same time, because they're so tightly coupled. So you've actually ended up in a worse situation than the original ball of mud. So services are supposed to help. They've made things worse. How can we avoid this? What led us down this path? Let's look at an actual use case now. Let's look at Amazon. Now, Amazon's a great example because Amazon is I'm sure you've bought something on Amazon or something like it at some time, right? E-commerce is a known thing. But Amazon's a great example because Amazon is highly service-oriented. So there's a famous email that went out from Jeff Bezos, the CEO, and he said, everyone will do everything service-oriented. Anyone not doing so will be fired. Right? He actually sent that email out. So there's no 1 terabyte Amazon.exe that gets rolled out. It's like there's a huge number of various components and things that belong to different services. Now, when you buy something on a site like this, what you do, you fill up your basket, and once you're happy, you say, right, I'm going to go for it, I'm going to buy this stuff. you start a workflow. And you start that workflow by clicking something like proceed to checkout. The next step of that workflow is to enter your shipping details, right? Where do you want this thing to be shipped? The next step might be to enter your credit card details and then shipping options and so forth, until you come to the end of the workflow where you click Buy Now. Let's have a look at how that might look in the back end, right? So this is a very slightly simplified version of the Amazon back end. I'm just going to assume a kind of sales, finance, and shipping service. When we get to the end of that workflow and we click Buy Now, we can send a message to sales to say, place this order, right, with all these goods and things. Sales can do salesy kind of stuff, right? Are we allowed to sell this product in this country? If we've still got it in stock, if not, can we order more? And that kind of stuff, salesy stuff. If it's happy with all that, it says, yep, we can go for it, we can fulfill this order. It publishes an event to finance to say the order's been placed and to shipping that the order's been placed. Finance does financy stuff, right? It goes and actually gets the money from the customer, right? Charges the credit card, whatever it needs to do. It can then publish an event to say the order's been billed. Shipping now sees that, the order's been placed, it's been billed, I can now do shipping-y stuff and actually get the thing to the customer, right? So that's fairly straightforward so far. It could potentially raise another event to say the order's been shipped, and something else could react to that, like, I don't know, sending an email to the customer or updating their customer status or something like that. Now, what should each of these messages contain? Should order placed contain all the information that finance needs in order to bill the customer? Should order placed contain all the information that shipping needs in order to get the thing to the customer? Now, that would work. Okay, there's no reason that wouldn't work. But what's the problem with that? We're back to that coupling. Because all of a sudden, sales needs to know all about stuff that finance needs. And sales needs to know about credit card details. Sales needs to know about addresses. What if one of those great ideas that the business come along with is charging in Bitcoin, right? All of a sudden, you have to make a change in sales so that it knows about Bitcoin, a change in finance so that it knows about Bitcoin, then you roll them out together, and you see what I mean? This is a simple example, but you can see how things are going to get complicated. What about if we want to start shipping ebooks, right? You don't ship an ebook to an address. I mean, you could put it on a USB stick, but it would just be weird, right? You send an email, you give them a download link. That is shipping an ebook, right? So we don't want to make changes in sales and in shipping to ship ebooks. And think about what that event's going to look like. That event's getting very fat, and it's got all these nullability rules, like, well, either the address must be not null, or the download link something must be not null, or the Bitcoin wallet ID, or the credit card detail. One of those must not be, and it's a big, fat, complicated event. What we want to do is we want to slim that down to a thin event. What if we could slim that event down so that it was just an ID? Just an ID. So sales said the order's been placed, and the order ID is 123. Finance says, right, order 123, I'm going to bill for that now. It does its billing, and it's been billed for, order 123. Shipping says, the order's been placed, the order's been billed, what's the order ID? 123, right, I'm going to ship it, and so forth. Now that seems okay, but how can finance know anything about order 123? Right? Right, order's been placed 123. How can it know how to charge for it? Now the thing is, how can it even know anything about order 123? Because when we start this workflow, our assumption so far is that sales will say, right, the order's good to go. It writes a row into its database with an order ID, and that's where the order ID gets created. Now, this is where I'm going to turn something upside down. That's assuming that the order ID is created at the end of the workflow when we click Buy Now. What if we turn that upside down and say we're going to create the ID at the beginning of the workflow? So when we click Proceed to Checkout, that's when we create the ID, right? It can be a GUID if you want to, or a UID, or it can be an integer, whatever it needs to be. Then, when we proceed through our workflow, When we tell the system our address, we can send a message to shipping to say, this is the address for order 123. We can send a message to finance to say, this is the credit card details for order 123, and so forth, until you get to the end of the workflow and you send a message to sales to say, these are the goods that have been selected for order 123. Let's have a look at that in the back end. So during the workflow, we send a message to shipping to say, this is the address, with the order ID and the address that shipping needs. We send a message to finance. This is the order ID, these are credit card details you need. We send a message to sales. This is the order ID, these are goods that have been selected. Now, sales does its work, exactly as it did before. But now it just publishes order placed just with an order ID. Finance says, yeah, you told me during the workflow what the credit card details are for order 123. I know how to charge for those, and it goes and charges them. Shipping says, right, okay, so the order's been billed, the order ID is 123, the order's been placed. You told me during the workflow what the address is for order 123. I know how to ship it. I ship it. And then I say order's been shipped and ID, and so forth and so forth. Now, what happens now if we want to introduce Bitcoin payment? We make a change in finance so that it can accept not only Bitcoin, but credit card details. Not only credit card details, but Bitcoin in this address here, in this message here. What if we want to use ebook shipping? We make a change in shipping so that it can accept details for shipping an ebook here, not just a physical address. We can make that change just in that service. Now, the one weird trick that's allowed that is creating the ID not at the end, but creating the ID up front. Now, there are a couple of things I'm glossing over here, which I'm going to go into. Who here works with databases? Anyone? A database anywhere in your system? That's most of you, right? So I suspect that a few of you are thinking now, well, what happens if I enter my address, enter my credit card details, then my partner walks through the door and I get all of a sudden guilty because I spent too much money this month already, and I close my browser window and don't finish my order? Aren't we going to have redundant data, right? We've got this messy, redundant data sitting in shipping and redundant data sitting in finance for an order that's never going to be completed. Right? We've got to clean that stuff up, right? It's useless. Is it useless? Would a business be interested to know which types of orders are being completed and which ones are being abandoned? Would they like to A/B test something to make it more compelling to complete those orders which are getting not completed? Maybe. This can actually be really good business analytics, right? They can actually make use of this data. It's not necessarily redundant. And thank you, you're going to restart outside active hours. That's good to know. Everyone knows that now. Where was I? Yes, so even if it's data in a database, data storage is one of those things that is genuinely getting very, very cheap. Right? So if it's thrown in a database, that's not very expensive compared to how useful that data might be. Sometimes it's not necessarily data in a database. With finance, you may have to be a bit careful about storing credit card details. You might just put it in some kind of session state. Right? You close the browser, session times out, it just vanishes. Right? So it's not necessarily redundant data or costly data. Now, the other thing I'm glossing over is how should the UI get the information to finance? So this UI component has to change because it has to have like a kind of radio button, credit card or Bitcoin. So isn't the UI going to be kind of tied to all the services in a kind of like highly coupled way? Well, what if finance owned this part of the UI? The finance service actually ships that part of the UI. Now, I'd love to go into that in more detail right now, but that's another hour talk. So if you want to, follow this URL. This is a link to a recording of a webinar by a colleague of mine, and he goes into actual technical details of how you can do that in the UI. If you miss this UI, don't worry. My Twitter handle is in the top right, and I will publish these slides directly after this talk, so you'll be able to grab it from there. So why is it that we ended up in a big ball of mud? Because that sounded great, but why did we end up in this big ball of mud? Well, it all started here, right? It all started from sharing data between services. So at this point, I think it's a good time to try and define what a service actually is. What does this word service actually mean? First of all, what is not a service? So something that just has functionality, like a validation or a calculation or something like that, that is not a service. That is just a function. That is what a function is. Something which is only data, create, read, update, delete on entities, CRUD, that is a database, right? That's what that thing is. And really importantly, just because you sprinkle HTTP on top of a database, it doesn't make it a service, right? And that's some of the literature, from a few years back, kind of led us down that path. It's not kind of service magic dust to put HTTP on top of a database. All you've done effectively is changed your entry point from a connection string to URL. It's still just a database. Rather, a service is the technical authority for a specific business capability. And very importantly, it contains all data and all business rules to do with that business capability. And everything belongs in a service, right? You don't have service A, service B, service C, and the other kind of stuff. Because that stuff there is where all the most interesting questions are, right? You can't sweep stuff under the carpet and say that's the MISC bucket. That's where the most interesting questions are. That's where the real service boundaries will reveal themselves when you answer those questions. And this makes sense because what is a company? It's a set of business capabilities. And the code that we write should be serving the company. It should be serving business capabilities. Unless your project's completely failing and you know that, and you just go and learn Rust or something, that normally you should be writing code for a business purpose. So it follows that all code must belong in some kind of service. Now, it's a bit similar to object-oriented programming in a way. So if you've ever read anything by some of the people that originally wrote about object-oriented programming, like Alan Kay, they never really wrote about polymorphism and inheritance and that kind of stuff. An object to someone like Alan Kay was something that got messages in, encapsulated some data and some business logic, and sent other messages out. Now, it's quite a good encapsulation, but if you've ever worked with C# or Java or any object-oriented programming language, you know that it's not quite strong enough. It can't completely encapsulate. You have methods with arguments. You have properties and objects. So then you can step up to, say, components, right? And a component might be something like a .NET assembly or a Java jar file. I think I'm not a Java person, but some kind of physical component with many objects or many types. That's a stronger encapsulation, but you still end up having a public API with some kind of methods and arguments and data on them. A service is then a level above that. A service is a complete encapsulation that shares no data. And the key thing that allows it to be that is that it is not a physical thing. A service is a logical concept. This becomes very clear when we compare services with systems. So imagine we have a mobile system, a .NET backend, and some kind of Java portal. Now those are systems, and it's tempting to sometimes draw our service boundaries along those lines. Right? Back-end service is something I've heard a few times in my career. But services cut across those things. Services, if you like, are kind of vertical things that cut through those various systems. So what this implies is it's a many-to-many relationship. So one system may have components from 3 services, from many services. One service may ship components into many systems. All right, it's almost like, I don't know if you've ever played with Lego, right? So when you play with Lego, you have that kind of green board. And I used to be very specific about this. I used to organize my bricks into big bricks, medium bricks, and small bricks, or yellow bricks and white bricks and blue bricks or something. And then you pick bricks from each pile and build a system. That is what it's like to compose a system from components from services. Services are logical design time concerns based around business boundaries. Systems are physical runtime concerns with technical boundaries. If there's one thing I'd like you to take from this talk, it's this, right? Because separating the physical from the logical is even more fundamental than finding your right service boundaries. Because if you can separate the physical with the logical, it allows you to find the right service boundaries. And if you do not separate the physical from the logical, it will prevent you from finding the right service boundaries. So it's even further down the route than finding the right service boundaries, separating the physical from the logical. Let's have a look at something more concrete, right? So you might speak to your business and say, well, tell me about the domain. What is this domain? What do we do? We have products and we sell them to customers, right? So the first thing you like to do is you like to go to the whiteboard and draw a box for product and a box for customers, right? And they start to tell you about the details. It's like, oh no, we'll go into the details later. Let's find out what entities we've got. And sooner or later, they might become classes, and you might find out with things like customer has a first name and a last name, and customer has a status, and product has a name, a description, and a price. Now, things become interesting when you start to look inside these boxes. The thing about businesses is that they often don't know what they want, but they almost always know what they don't want. And you can take advantage of that. You can ask dumb-sounding questions like, if a customer's name starts with an S, does that affect their status? And the business will look at you and say, you don't really understand this domain at all, do you? Not only would we never do something so dumb, no one in this industry would do something so dumb. Now, you've just struck gold. Because what have they just told you? They've told you there's no relationship between a customer's name and their status. Stable business rule. Now you have to ask yourself, why are they in the same box? What you're trying to do at this stage of modeling is you're trying to create piles of related things. I'm going to put the customer's first and last name in one pile. I'm going to put the status in another pile because you've told me they're not related. Now you can look at what you've got in that middle pile. You've got customer status sitting there on its own. You can say, what is customer status? It looks a bit lonely there. And they say, well, we use that to work out the price. Because if a customer's gold status, they get 20% off. If they're silver status, they get 10% off, and so forth. Okay, so customer status and price are related somehow. Great, so I'm going to put price in the same box as customer status, because I know that they're related. Then you look at what's left. Well, you've got the product name and description. They kind of go together. You know, if a product is a luxury something or other, you want the description to tell you why it's luxury and why it's so great and why you need to buy it. So you put those together in another pile. Now, you can see that the model that's revealing itself on the bottom is very different to the one on top. And this is an incredibly simple example. Imagine if I had 10 classes up there, each with 10 properties. Imagine the different model that will come out from that if we started asking those questions. Modeling is not about nouns. Okay, so customer and product are nouns, right? Entities. That's not what modeling is about. And this is tough, right? This is tough for us because our brains are kind of wired towards tangible physical things. You say to me product, I want to draw a box for product. I want to draw that box for customer. You know, that's some kind of solid concept. But that's not what modeling is about. It's not the entity, it's the field. It's not the noun, it's the use case, the scenario, the behavior. That's what modeling is about. Anyone read Eric Evans' Domain-Driven Design, the blue book? That's quite a few of you. Now, if you were like me, you read about entities and aggregate roots and value objects, and you got all excited, and you ran to work and started writing them. Now, you may have heard this before, but Eric has since said that he wished he put all that stuff in the second half of the book because it distracted everyone from the much more valuable stuff which is currently in the second half. Later on, he said he wished he'd just put it in an appendix. Later on, he even said he wished he'd left it out altogether. I'll go ahead and say it. Entities, bad. Use cases, behaviors, and scenarios, good. Now, another thing that I can... One more thing. Customer has a first name. Look out for that bit in the middle, has a, right, or whatever the local language equivalent is. If you hear has a, it's a very strong sign that you're going down an entity-first approach, and you're going to end up with a model much similar to this instead of something similar to this. Do not name these things too early either. Right? I recommend just giving these things dumb names like red, green, and yellow, or names of planets, or names of animals, or whatever. The thing is, if you name these things too early, you might fall foul of two possible problems. You might look at a piece of data and say, oh yeah, that's got to be inventory. Right? You actually skip past the use cases and you say, well, that thing there's inventory, this thing clearly belongs in there just because of the name. And sometimes you have the opposite problem. Sometimes you have a piece of data, you're looking at the use case, and it's telling you it should be in billing, but it can't possibly be in billing. That doesn't sound right. So it can stop you from putting things in the right place just because of the name. I've actually worked on teams where we never gave these things meaningful names. We actually used kaiju monsters, so Godzilla and Godzuki and other less well-known ones like Mothra and Udaku. And we just left them call that thing forever, call those things forever. We said, look, we know what Mothra does, we know what kind of thing Udaku does, there's no point trying to give these meaningful names, it's not really going to add any value. I just stayed there. Let's have another look at another example. So insurance. Insurance is quite interesting. Said no one ever. No, I jest. It is actually an interesting thing to analyze and examine. Does anyone here work in insurance? Anyone? Right, a few lucky people, right? So you're going to know what I'm talking about. If I get this completely wrong, please tell me. But insurance, it's a little bit like, in some ways it's a bit like banking, where I spent a bit of my career, in that it kind of has a front office and the back office. So the front office is kind of all about selling policies, and ultimately that's about fear. It's making people afraid enough about bad stuff happening that they're going to buy insurance in case it happens. Actually, I don't know what it is in your local languages, but I gave this talk in Russia once, and someone came up to me afterwards and said, the word for insurance in Russian has the word fear inside it. So there's some truth to this somewhere. And the back office of an insurance company is about dealing with claims. So something bad happens, you send a claim, they work out how little money they can get away with paying. Right? How little can we get away with paying for this claim? Now that sounds a little bit cutthroat, but ultimately that's the model of any successful company, right? Maximum money in, minimum money out, and you're gonna work. Now, a colleague of mine was actually asked to come to an insurance company to have a look at the service boundaries. They said, we're not sure if we've got them right. We want you to have a look. We want to know what you think. And they actually showed him this. They showed him a policy service and a claims service. Now, I don't know anything about running an insurance company. I know a little bit about what insurance is and how it works, because I have insurance and I have made claims. But I can say, quite safely, that this is wrong. Why can I say it's wrong? Think about a use case, right? The dog chews up my sofa. I send a claim to my insurance company. What's the first thing that the claim service is going to do? Check the policy, right? It's going to check all the small print. Now, can we get away with not paying this? Is the first question they try and answer. Now, you can publish the policy to claims when it's sold, or claims can retrieve it on demand. It doesn't really matter. But that is red lines going between those services, right? That is a high degree of coupling. You want to make changes, you've got to change both in many scenarios, right? We want to avoid that coupling. That's why I can say that's wrong, because they're going to be highly coupled. Now, it's all very good saying it's wrong, but my colleague was called in for a week to do this, and by Thursday, they're kind of saying, well, okay, on Monday you told us everything was wrong. Have you found the right stuff yet? And you kind of say, oh, I'm getting there. And you give them nice answers like, that meeting you organized yesterday, that was great, it's definitely getting there. And meanwhile, you're kind of scratching your head, and it can be very stressful, actually, and it can be very tough to find the right service boundaries. It's almost like you're kind of wandering around and bumping into stuff in the dark and, knocking things over, and it feels clumsy, but things eventually, you might get a flash of insight. You might realize that, what, in all the use cases we've talked about, I've never heard you say something like, well, when I crash my car, I show the company my sofa. Or when my plane ticket gets cancelled, I show them my damaged car. I'm not hearing about home insurance, travel insurance, and car insurance in these scenarios together. So I can it seems to work if I draw them separately. I think, right, I might be onto something here. So it gets to Friday, you book the biggest meeting room in the building, you call all the seniors together, all the stakeholders, you stand up at the front and say, guess what? I've had a huge insight. Home insurance is different to travel insurance. Travel insurance is different to car insurance. And the same thing for car insurance and home insurance. And the business look at you and they say, how much have we just paid you to come in here and tell us something we've known our entire careers, and the industry has known for the last 50 or 100 years? Now, you've just struck gold. Because what they're saying is, that's obvious. If your use cases and your scenarios and your behaviors are leading you to this model, and the business says that's obvious, that's a very strong indicator you've got it right. The thing is, then, you might ask yourself, well, silly me, why didn't I just ask you in the first place? Why didn't I just say to you in the first place, how is your business organized? The thing is, this stuff on the bottom is obvious, so is the stuff on the top. It depends who you talk to in the company. It depends on their position, on their experience, on their aspirations. You might get lucky. They might say, oh yeah, we've got home insurance, travel insurance, and car insurance. Or they might say we've got a front office and a back office. Or they might say we've got customers and policies, or customers and products. There's so many ways to split and analyze this business at the higher level. But that's an illustration of why modeling, service boundary modeling, is not a top-down exercise. It is a bottom-up exercise. It's looking at the scenarios and the use cases and the behaviors, looking at the data. People say to me, look, do I really go and look at all that detail? Do I really have to analyze all that data? The answer is yes, because that is where the best service boundaries reveal themselves to you, by looking at that stuff at the low level. And this stuff at the top here is just one example of an organizational boundary. Okay, so it would be really nice, it would be absolutely fantastic if we could go into a business and say, all right, how's your company organized? Yeah, we've got sales, marketing, and finance. Okay, those are your service boundaries, off you go. That would be great, right? But the problem is, I think that may have worked at one time. If you think about businesses before we automated everything with computers, data was stored on paper. And paper was stored in filing cabinets. Data access was actually very expensive. So imagine if you needed some data for your job, and one piece of paper was in the filing cabinet at one end of the building, another was at another end of the building, another one at the front of the building. That would be very expensive to gather that data, right? So what tended to happen is you tended to have your filing cabinets near you that you needed for your job, or in the same kind of room with everyone else that used those filing cabinets. And you kind of get a request through, you go to your filing cabinet, pull out the piece of paper, you fill in some stuff, maybe send a note to someone in your outbox, and some trolley person will come along and kind of move that across the building into someone else's inbox. They would go to their data, do their stuff, send another message out, and so forth and so forth. So companies were almost forced to be service-oriented. Right? They were actually forced to encapsulate data and logic by a department, right? Department by department. Then we came along with our fancy databases and our fancy computers, and we put one on everyone's desk, and what did that do? It made data access incredibly cheap because everyone could access potentially any data at any time, anywhere. Sometimes it's just a case of having the right security flag set, knowing the right person. So data access was very cheap. Now, managers have taken advantage of that. I've seen in my career a manager leave and other managers fight for the scraps of his whole department. So, I'll have that bit there, thank you very much. Oh yeah, I'll have that bit there. And why? Because you tend to get promoted in organizations based on how many boxes are under you on the org chart. So the modern department has become a kind of mini kingdom or fiefdom. And if you're to model your service boundaries around that, you may well just be modeling a manager's skills at empire building rather than business rules, rather than business capabilities. One big problem with these things is that they tend to change very often. So the last big company that I worked for, my organizational unit once changed 8 times in 1 year. Right? Because managers were leaving, managers were joining, they were shuffling things around, there were politics going on. So it's not a stable business abstraction. It's not a stable business. These are not stable business rules on which to base your service boundaries. And it is a real shame, right? It'll be a lovely shortcut, but it doesn't tend to work. So beware the organizational boundary. Now, I did promise to talk about microservices. I think some great stuff has come out of microservices, right? Some really cool stuff has come out of this, the whole microservice movement and literature. But I do have one big concern, which I'll try and illustrate to you. So, microservices are ultimately another weapon in our battle against the big ball of mud. Right? So we read about microservices, we think we can split these things up into smaller things that we can look at one at a time, and we split this up into, say, 5 microservices, and then someone comes along and says, yeah, they're a bit big. You haven't really many of them. We need to split these up a little bit more. They need to be a bit more micro. So you split them up a bit more, and we end up with 13. And you think, right, we must be doing microservices now. But then someone says, we need to optimize for deletion. Right, you should be able to delete a microservice and rewrite it within a week. That's a good heuristic to say whether it's big enough or small enough or whatever. And someone else says, and I've heard this before as well, it mustn't be more than 300 lines long. But anyway, for various reasons, you split it up even more. So you split it up into a few more microservices, and we must be doing microservices now. We're even using Docker and things now. And that looks quite nice, right? You can see the areas of responsibility and the lines of communication. Sooner or later, the business will burst into your workspace and say, I was out snowboarding last weekend, we had a great new idea, can we do it? And you think, we need a bit of data up here from something down here. This is kind of what microservices is designed for, though. They're designed to be called by other microservices. They've got nice interfaces, nice areas of responsibility. What happens if we just make the call? And sooner or later, you come in and you find the same thing happening again. And yes, this looks familiar. You know where I'm going with this, right? Given enough time, a year, 2 years, 3 years, you may end up with something which looks a bit like this. And we've seen we can take the blinds away, we can take the boxes away, we're back to one big box, we're back to the big ball of mud. Only this time it's a big ball of mud with a difference, because you've rolled it out onto 100 Docker containers. They're talking to each other over the network. Oh yeah. Anyone seen that famous Stack Overflow question? I can't find it for the life of me. It's difficult to Google, but I remember reading this. I said, we've got problems. An HTTP request comes in, and we form 28,000 microservice calls in the back end. It's a real thing, honestly. I just can't find the thing. It's difficult to Google for it. And I just, I'm glad you're having problems. It's showing nanoservices. Maybe that's the term. Yeah, I'm going to look for it again. I'm determined to find it. you have, and okay, you may be using like stuff like Kubernetes and stuff to do the orchestration, and you've got this fantastic deployment system. You can roll out 10, 20, or all of them at the same time. We did that last week because we had to. They're so coupled. You've ended up with a big ball of mud microservices edition, right? And again, this is a real shame because microservices were supposed to help, right? And you can easily end up in a potentially much worse situation. What we want are logical service boundaries, right? With IDs going between them, as we've seen. Within those, we may have different components, right? We may have components to pull out into a system. So you might choose a component from here, component from here, component from here, put them onto your green Lego board and ship a mobile app. Within something like this might have a responsibility like something to do with bank accounts. And it has to generate bank statements and it has to lock accounts for fraud. Bank statements, I mean, what's the SLA on bank statements? They should go out on the same day each month. If something really bad happens and they go out a day later, are you going to get out of business? Probably not, right? You might get a few complaints. So you put the bank statements component, the 2, 3 VMs for a bit of redundancy, and things are kind of good enough. Fraud, the business are going to say to you, look, if we detect fraud on an account, you need to lock it now, right? Instantly. Because if fraud is happening on several big accounts, that actually could put you out of business. So with fraud, you do all that funky microservice stuff, all that funky stuff you've read about, all those nice deployable units and all that elastically scaling and having 20 competing consumers on a queue and making sure that they're all fighting for messages when they arrive. That's why we split these things up. That's another reason for splitting these things up within those logical service boundaries. Now, you might ask, is it possible that we're getting into a mini ball of mud here? Right, this one here is starting to look a bit complex. Now, I'm not going to say it's impossible, right? If you've got enough determination, you can create a mess using any architectural style. But I will say it's less likely, and that's what this is all about. It's making that less likely, because we split these things up in here, not so much for technical reasons, but we actually do it for business reasons, like the SLAs. Or we do it to separate the physical from the logical with the systems and services. So it's less likely. Now, up here, you can see that the physical boundary and the logical boundary happen to align, right? For this service, it actually just makes sense to write one component, right? Just by chance, but it's not an architectural constraint. And the thing is that a lot of the microservices literature doesn't make that distinction. It doesn't make the distinction between the physical and the logical, which remember is the one thing that I wanted you to take from this talk. So that's my concern with microservices, is it distracts us from finding the larger logical service boundaries. And it distracts us too much in thinking that the logical equals the physical boundary is our service boundary, and it is a logical boundary. You need to make that distinction, and that's my concern with microservices. Yes, I know you've already told me. Thank you. Now, if you want to, you can call this thing in here a microservice. I won't be annoyed if you do that. I don't like the word microservice. 2 reasons. Micro. I think, is size important? I don't think it is. Service, right? It's another overloading of the word service. It distracts us from the very crisp and defined concept of a service in service-oriented architecture, which is a logical boundary. I've scratched the surface here. Right? But what I've done is I've prepared a set of videos for you. If you go to this URL, this is a set of videos from a 5-day course run by a guy named Udi Dahan, who's actually the CEO of our company. So follow that URL, grab those videos. I would just finish off by saying, and again, yes, I will publish the slides.